This is lesson 7.8, and it is called Systems of Linear Inequalities. And what we're going to do here is basically do what we did in lesson 7.7, but for each problem we're going to do it twice. So if you have something like 2x plus 3y is less than 6, and you were to put this in the right form, so set it equal to y, so we'd have 3y is less than negative 2x plus 6, divide by 3, and we get y is less than negative 2/3 x plus 2. Okay, and that's in slope-intercept form. It's in the y equals mx plus b form. And we have a graph, and we are to graph that. And our y-intercept is 2. So 1, 2. So there's 1 point. And our slope is negative 2/3. So, if you remember, we look at our negative 2/3 as y over b, or y over x. So we are going to go down 2 over 3. For this point there, we're going to draw a line, and because this is a less than sign, it's not an equal, then it's a dotted line. So this is all old stuff that we did in the last lesson. Then we plug in a number on this side of the line. So let's say we put in 0, 0, so x is 0 and y is 0 into this equation. 2 times 0 plus 3 times 0 is less than 6. So 0 plus 0 is less than 6. Is that a true statement? Yes, it is. So because that's a true statement, everything below the line gets shaded. Alright, that's what we did in 7.7. 7.8, the only difference is we're going to have two inequalities, and we're going to graph both of those lines on one graph, and then I'll show you what we'll do with that. Okay, so let's try one of these. Let's try x plus y is less than 4, and negative x plus y is less than or equal to 3. Okay, so what we're going to do here is we're going to graph both of those inequalities and then see what they have in common. So let's look at the x plus y is less than 4. Alright, so if I make a little table here and I put a 0 in here for y, x, then y is going to be 4, because remember, we take this and we make it as x plus y equals 4, and we graph that line. 1 plus 3 equals 4, 2 plus 2 equals 4, and we'll leave that as enough. So let's go ahead and graph that. 0, 4, 1, 3, 2, 2. So we get a line that goes like that, but because it is a less than sign, it's going to be dashed instead of solid. So let's go ahead and make it green, dashed here, since I can't erase the yellow. So it's going to be a dashed line like that. Okay, and then we're going to try numbers in there and see what happens. So let's put in 0, 0 to see if it's shaded above or below. So 0 plus 0 is less than 4. Is that a true statement? Yes, it is. So because it's a true statement, this is going to be shaded. Okay, let's go ahead and graph that one now. Let's put it down here. So all we're doing is graphing two inequalities on the same graph. Alright, so let's go ahead and make this equal. So let's do an x and a y. So if x is 0, y has got to be 3. If x is 2, then we've got negative 2 plus something is 3, and that something would be 5. And let's go ahead and graph that. So 0, 3, and then 2, 5. Okay, now notice this is a less than or equal to sign, so that means our line is going to be solid. So now what we're going to do is we are going to look at that equation and put a number below the graph or above the graph in for x and y and see if it's a true statement, and if it is, then we're going to shade. So let's take 0, 0 again. So we'll put it in for that. We got negative 0 plus 0 is less than or equal to 3. So is 0 less than or equal to 3? Yes, it is. So because it is, everything, and I'm going to do this in blue, everything below that line is going to be shaded. Alright, and notice here that where we shaded below the dotted line was yellow, below the green line was blue. Where they cross, this intersection here, that ends up being the answer that we're looking for, is what they have in common with each other. So this here is going to be the answer. So we don't have to solve anything. We're just graphing and figuring out where they overlap each other, and that'll be the answer. Okay, so that's kind of messy. Let's go ahead and do example 1. Okay, so there's our two problems for example 1. Fortunately, they are in slope-intercept form. So all we're going to do is make them equal instead of writing them as inequalities, and graph each one. Okay, so let's graph this one first. And it is graphing it with y equals mx plus b, slope-intercept form. 3 is the y-intercept, and 1/2 is the slope. So the slope is up 1 over 2, up 1 over 2. So we end up with a dotted line that does that. Okay, now we're going to look at the second one here. And the y-intercept is negative 2. And the slope on that is 1/2. So that means our y over x is 1 over 2. So up 1 over 2. Up 1 over 2. And because of our greater than or equal to sign, we get a solid line. Okay, that's not a very good solid line. Let's see if I can get one that's a little bit. That one's not good either. Okay, we'll just leave. We'll call that good. Alright, so now we look at our yellow or our green line, and we pick a number that is somewhere below it, and we plug it in here and see if that's a true statement. So I'm going to put 0, 0 in because that's below the line. So 0 is less than 1/2 0 plus 3. That one right there. So 0 is less than 3. Is that a true statement? Yes, it is. So everything below here gets shaded. If that was an untrue statement, then everything above would get shaded. Alright, let's look at the second equation here. Second one is y is greater than 1/2 x minus 2. That's from this one here. So now what we're going to do is we're going to look at numbers that are below here and see if that makes this a true statement. and go from there. So let's pick a number like 1, 2, 3, 4, 1, 2, 3, 4. This number right there, and see if when we plug that in, we get negative 4 is greater than or equal to 1/2 times 4 minus 2. So negative 4 is greater than or equal to 2 minus 2, or negative 4 is greater than or equal to 0. Is that a true statement? No, it is not. So that means that the stuff down here does not get shaded, but rather the stuff above gets shaded. So all of this gets shaded. Alright, so again, what we're looking for is, and we'll do this in blue, what we're looking for is where the intersection is. The intersection between those two inequalities is right in here. This is what they have in common. So then I make sure my red line is solid, and I need to also make sure my green line is still here and it's dotted, but everything else in between is shaded there. Okay, so that's it for example 1. Let's jump to example 2 on the next video. That ends up being my answer.